back to Moments with Chemistry. So today we are going to continue with question number 11 of the 2019 new syllabus chemistry MCQ paper. Okay. Question number 11. The correct answer when the chemical species sulfur dioxide, sulfur trioxide, sulfite, sulfate and HCl2 are arranged in the increasing order of the electronegativity of the sulfur atom. Electronegativity of sulfur atom. Okay, now what is electronegativity? Ability of an atom to attract a bonded pair electrons to itself. What are the factors on which electronegativity depends? Hybridization, charge, oxidation state and the arrangement of atoms. But the first priority should be given to hybridization. So look at this. Sulfur dioxide, sulfur trioxide, SO3 2 minus, SO4 2 minus and HCl2. So if you consider sulfur dioxide, this is the molecule 4, 5, 6. sp2. Sulfur trioxide is also the same thing, sp2. Sulfite, SO3 2 minus, SO3 2 minus, 1, 2, 3, 4, 5, 6, sp3. Sulfate, sp3. HCl2, HCl2 is like this, look at this, SCl2, sp3. So you know that higher the S character in the molecule, higher will be the electronegativity. So the electronegativity of sp3 is the least, then sp2 and highest is sp. Okay, now here we have 3 sp3 and 2 sp2. Still we can't differentiate between the species that have the same hybridization. Next one, so the first criteria I took was hybridization. Second criteria, charge. Charge is 0 for all the species because sulfur will not get plus or minus in any of the stable Lewis structures. Next one, oxidation state. So this is plus 4, plus 6. This is, how much will be this? Look at this. X minus 3 to 6 equal to minus 2. So x equal to 6 minus 2, that is plus 4. So the oxidation state for sulfite is plus 4, sulfate is plus 6 and HCl2. Look at HCl2. Which one has the higher electronegativity? Chlorine. This is plus 2. I think from this you can take. So higher the oxidation state, higher the electronegativity. Why? They can pull more and more electrons. More and more electrons from the bonded pair are pulled. So your variation should be highest is for sp2 now, and from that also the highest oxidation state. SO3. Next one SO2. From these highest oxidation state sulfate SO4 2 minus. Then SO3 2 minus. Finally HCl2. So the highest one will be sulfur trioxide. Next will be sulfur dioxide, sulfate, sulfite and HCl2. So the correct answer that gives this particular variation is the fourth one. 11th question, your answer is answer number 4. 11th question, answer is answer number 4. So when you are told to speak about electronegativity, always speak about hybridization, charge, oxidation state. Very well, if they give you something like HCl2 and SF2, we have to give priority to SF2. That is because of the electronegativity of the atom that is bonded more adjacent to sulfur. So that particular thing has not been tested here. So we can come up to a spotlight answer, the fourth one, if I am not mistaken. Yeah. Question number 11, your answer will be the answer number 4. Okay, the next one, question number 12. That is also a calculation question. Which of the following answers gives the maximum hydroxide concentration that can exist in a 1.775 mole per cubic decimeter aqueous solution of MgCl2 at 25 degrees Celsius. At this temperature, the solubility product of magnesium hydroxide is 7.1 into 10 to the power minus 12. This is also a very good question. Look at this. We are supposed to find the hydroxide concentration in a solution of MgCl2 that has been dipped within water. So look at this. You know that MgCl2 is a salt that belongs to the S block. So MgCl2 aqueous completely dissociates to give you Mg2 plus aqueous plus 2Cl minus aqueous. So if this concentration is 1.775 mole per cubic decimeter, magnesium 2 plus will be 1.775 mole per cubic decimeter, and the chloride ion concentration will be 1.775 into 2 mole per cubic decimeter. Okay. We are supposed to find the hydroxide concentration. Magnesium hydroxide solid reversibly gives you magnesium 2 plus aqueous plus 2OH minus aqueous. So the magnesium 2 plus ion concentration is 1.775 mole per cubic decimeter. Hydroxide concentration is unknown. Assuming that this particular solution is saturated, assuming the saturated nature of this solution, I can write Ksp equal to magnesium 2 plus aqueous concentration into OH minus aqueous concentration, but how much? Square, very important. So assuming that the magnesium 2 plus concentration that comes from magnesium hydroxide to be negligible when compared to the amount that comes from magnesium chloride, magnesium 2 plus coming from magnesium hydroxide is considered to be negligible in comparison to the one that comes out of magnesium chloride. So if you want, you can say this is 1.775 plus x by 2. But here this x by 2 mathematical component will become negligible. So that's okay. Ksp value has been directly given to us, 7.1 into 10 to the power minus 12. 7.1 into 10 to the power minus 12 mole squared Bm minus 6 equal to magnesium 2 plus aqueous concentration is 1.775 mole per cubic decimeter into x squared. So if you solve this, x squared equal to minus 12, no, we will consider it to be just minus 12 into 10 to the power minus 12. Look at this, 1.775 if you multiply it by 4, 1.775 into 4, 5 4s are 22 remains, 7 4s are 28, 29, 32 remains, 7 4s are 28, 29, 32 remains, 4 1s are 4, 5 6. It will roughly come up to that value. So 4, so x equal to 2 into 10 to the power minus 6 mole per cubic decimeter. 2 into 10 to the power minus 6 mole per cubic decimeter. So your answer for question number 12 is 2 into 10 to the power minus 6 mole per cubic decimeter. That gives you the second answer. Answer for question number 12 is the second answer. Question number 13. What is the major product of the following reaction? They have given you, okay, this is okay now, 2 into 10 to the power minus 6. I just considered that MgCl2 completely dissociates. Then considering Mg2 plus to be a common ion effect on this particular equilibrium, this Ksp equilibrium, again I wrote the equation, substituted, finally I have solved it and got x. But here x is how? X is what? X is the hydroxide concentration. Here, this part is what we have found here to be x. So no issues in that. So your answer is 2 into 10 to the power minus 6 mole per cubic decimeter. Question number 13. What is the major product of the following reaction? Okay. So that's also direct organic, but here this question they are testing you whether you know your organic coherently. That means whether you know to relate one subject you learn under organic, let's say for example alcohol, if you know to relate it to for example carboxylic acid. The relation in organic chemistry is the one that is preliminarily tested in this equation. Okay, in this question, sorry. So look at the product. Question number 13. A benzene ring. Here we have COOH. Here we have CH2OH. Here we have OH. If you add excess of aqueous NaOH, what will happen? Excess of aqueous NaOH. Carboxylic acid, will it react with aqueous NaOH? Yes. It's so acidic that even Na2CO3 or NaHCO3 can also give you the salt releasing hydrogen. So for sure we know no carboxylic acid should react. So this is CO, O minus Na plus. Phenol, yes, phenol will react for sure. So O minus Na plus. But alcohols are not so acidic like phenols. If you refer to the essay question that was given in 2018, actually it's a very good answer that they have given to compare the acidity between alcohol and phenol. So alcohol has lower acidity than phenol, so therefore alcohol portion will remain unchanged. The alcohol component of the organic compound, this alcohol component is going to remain unchanged. Only the phenolic compound will give you Na plus releasing this hydrogen, and the COOH releasing this hydrogen will give you the carboxylate ion. So the answer that gives you such variation is the second one. Question number 13, your answer is answer number 2. Question number 14. The bond angle of NF3 is larger than the bond angle of NH3. Identify the correct statement. Huh? That is wrong, no? Look at this. First statement they are telling the bond angle of NF3 is larger than the bond angle of NH3. We'll see why. What's the particular reason? Look at this. Both have trigonal pyramidal shape. NH3 and NF3. NH3 and NF3. You know that the electronegativity of fluorine is higher than the electronegativity of nitrogen. So what will happen? If there is a pair of electrons here, this pair of electrons that are there in the bonded pair, if this is the bonded bond, there is a pair of electrons. This electron comes from nitrogen, this electron comes from hydrogen. But these two electrons will move more towards nitrogen. Why? Nitrogen has high electronegativity. As a result, the electron density around nitrogen, he will also give more electrons towards this side, more towards this side, more towards this side. So we have electron-electron repulsion. Electron-electron repulsion means the bond angle will become greater. But here, the same two electrons, nothing new. Same two electrons are located closer to F. So the electron density around the central atom, whenever you talk about shape, concentrate on the central atom. If you concentrate on the central atom, you will never go wrong in any question. So this pair of electrons is pulled more towards fluorine. So therefore the electron density that exists around nitrogen decreases. So therefore the bond angle, if you consider, ammonia has a higher bond angle. Next statement. The elements in group 17 exhibit oxidation stage from -1 to +7. Yes, that's correct. -1 is exhibited by fluorine. +7 is exhibited by chlorine, Cl2O7. So that's a true statement. You can go for the second one. But just go for the next one also. Monoclinic sulfur is more stable allotrope of sulfur at room temperature. No. Rhombic sulfur is the one that is more stable at the room temperature. And when the temperature of the sulfur crystal is increased at a temperature at around 90-92, rhombic sulfur converts to monoclinic sulfur. So this exemplifies the fact that monoclinic sulfur is more stable at high temperature. So that's a wrong one. The density of graphite is higher than the density of diamond. Wrong. Then why the hell are we spending a lot of money to buy diamond? It's because its density is very high. Mass over volume ratio for diamond is higher than the mass over volume ratio that is for graphite. So that's wrong. Next one. Aluminium chloride satisfies the octet rule in gaseous state. Yes. AlCl3 is like this now. AlCl3. This is the normal configuration or the normal Lewis structure at room temperature. When it is heated, when it is in the AlCl3 molecule is within the gaseous phase, AlCl3 dimerizes. Two molecules of AlCl3 get together to form a new molecule. So 2AlCl3 will give you Al2Cl6 like this. Al2Cl6. So this is plus, a dative bond is formed in the middle. Yes, it satisfies the octet rule. Aluminium has 8 electrons, no? Jolly well, he is very happy. So that's also correct. So for question number 14, you can consider either 2 or 5 as correct answers. Both 2 and 5 are correct. Okay, question number 15. The standard electromotive force of the electrochemical cell, manganese and bromine, is 2.27 volt. So this is also from your unit 13, electrochemistry. The standard reduction potential of bromine electrode is 1.09. Standard potential of magnesium 2+. Actually for this, don't waste time writing the equation in a piece of paper. Try to get things mentally. But for safe side, we will write 15. Okay, question number 15. The standard electromotive force of the electrochemical cell, manganese and bromine, is 2.27 volt. The standard reduction potential of the bromine electrode is 1.09 volt. The standard electrode potential of the manganese electrode, you know that? E cell equal to E cathode minus E anode. Electrochemistry, unit 13, try to recall. So E cell is given 2.27 volt. But here, we know that according to our inorganic, group 17 elements act as very good oxidizing agent, which means it's easier for them to undergo reduction. So what is the cathode? Cathode is the electrode at which reduction takes place. So if it is easier for them to undergo reduction, bromine is going to function as the cathode. You have to make that decision taking into consideration your knowledge that you had gained in inorganic chemistry, unit 6, chemistry of SPD block. So cathode is bromine, 1.09 given. Manganese, then obviously anode, no? X. So if you solve for X, you get minus 1.18 volt. But if a student had marked, the correct answer is the second one, minus 1.18 volt. But imagine if a student had marked the fourth one, plus 1.18. So this exemplifies the sublime truth that that particular child has not studied his inorganic properly. Group 17 elements act as very good oxidizing agent. So here at the anode, manganese solid will become manganese 2 plus aqueous plus 2 electrons, and at the cathode, Br2 liquid will plus 2 electrons will become 2Br minus X. Okay, so that is the 15th question. 15th question answer is answer number 2, minus 1.18 volt. Okay, 16th question. The enthalpy change of vaporization and the entropy change of vaporization of a liquid are given. The boiling point of the liquid. Okay, this also has a small trick in the question. So this question also has a small trick. You know that when at the point of transition of a liquid to vapor, what is the process known as? Evaporation. Liquid to vapor. So during this process, energy is absorbed by the liquid, but temperature doesn't change. That is why it's known as latent. And at the same time, the delta G value is 0. Why? It's at equilibrium. So therefore delta G value is 0. 16th question. Delta G equal to delta H minus T into delta S. So delta G value is what? 0. Enthalpy change associated 45 kilojoule, so into 10 to the power 3 minus T into entropy change 90. So T will be equal to 45000 divided by 90. 500. But very careful, these people, okay, very good, they haven't given it. 500 Kelvin. 500 Kelvin means 227 degrees Celsius. You have to minus 273. Then you will get 227. So your answer for the 16th one is the 5th one. You just have to know that delta G0. That's the only thing that they wanted to test here. Others all are just simple mathematics. Okay, 16 answer is 227 degrees Celsius. 17th one, it's also organic. Correct statement regarding, this is diazonium chloride. First one, diazonium chloride can be obtained by reacting, incorrect are they asking, reacting aniline with HNO2, that is NaNO2 diluted HCl at 0 to 5 degrees Celsius, correct. For aniline, if you put NaNO2 diluted HCl at room temperature, it becomes phenol. If you add NaNO2 diluted HCl from 0 to 5 degrees controlling that temperature, you will be left with diazonium chloride. Next one, diazonium chloride reacts with Ki to give iodobenzene. That's also correct. I will get substituted on top. Diazonium, okay, the C6H5 N plus triple bond nitrogen can act as an electrophile. Yes, it is electron deficient. It doesn't have electron. So if it doesn't have electron, it should get it from someone else. So if someone is going to achieve, or they are going to absorb, or they are going to obtain electrons from an external source, they are obviously electrophiles. Then, when an aqueous solution of C6H5NaCl minus is heated, it decomposes to give benzene. That never happens. From diazonium chloride, if you need to get benzene, what should be done? H3PO2 heat. You can't just heat it. You have to add H3PO2 and then heat. Then only you get benzene. So fourth one is obviously wrong. So fourth is the answer. Fifth one, diazonium reacts with phenol in basic medium to give colored compounds. Yes, they form azodye with phenol. With phenol, it gives you what? An orange color dye. With beta naphthol, it gives you a red color dye. So that's correct. It gives colored compounds. That's correct. So 17th, your answer should be answer number 4. 18th one, calculation. H2S gas reacts with oxygen gas to give only water vapor, H2O gas, and sulfur dioxide as products. 4 cubic decimeter of H2S reacts with 10 cubic decimeter of oxygen at constant pressure at 250 degrees, the final volume of the mixture. Alright, we have to write the equation first. Then we will see how to approach. H2S gas reacts with oxygen gas to give you H2O gas and SO2 gas. See whether the equation is balanced. No, the equation is not balanced. See how I am going to balance the equation first. Oxygen, sulfur is balanced, H2 is balanced. So here oxygen 3 means this should be 3, this will be 2, 2, 2. So initially PV equal nRT. P constant, T constant. So therefore volume is directly proportional to the number of moles. So instead of working with number of moles in stoichiometry, we can work here with volume. We can work with volume here. Whenever you do any calculation, you can use volume. Why? They are directly proportional. Same temperature. They have given the particular temperature 250. So 4 cubic decimeter of H2S. So initial 4 cubic decimeter of H2S reacts with 10 cubic decimeter of oxygen. So what is the limiting factor here? H2S. So how much of H2S is going to react? So if I consider this one to be reacted or the formed amount, 4 will react here. So if 4 reacts here, how much of oxygen will react? This much of oxygen will react. How much of water will be formed? 4. How much of sulfur dioxide will be formed? 4. So finally in your mixture, 4 minus 4, 0. So the amount formed here is, reacted here is 6. So 10 minus 6 is 4, 4, 4. So total number of gaseous molecules is 4 plus 4 plus 4 plus 0. That is 12 cubic decimeters. So your answer for the 18th one is answer number 4. 18 answer is answer number 4, 12 cubic decimeter. Okay. 19th one, it's also a very good question. You have to know your theory properly for this. This is okay now? 4 plus 4 plus 4, 12. 19th one. A mixture of A gas and D gas was introduced into a rigid evacuated container at temperature T. At this temperature, both A and D decompose according to the elementary reactions that are given. 2A giving you B plus 3C, rate constant K1. D giving you B plus 2C. The initial pressure of the container is P, had changed to 2.7 P after complete decomposition of both the reactants. So both the reactants have to undergo complete decomposition. The initial rate of decomposition of A gas at this temperature is, R is the universal gas constant. Hi. 2A gas giving you B gas plus 3C gas. Rate constant K1. Then D gas giving you B gas plus 2C gas. Okay, this is a very good question. Initial pressure of the container is P. That means initially we have both A and D. We have P. So if I consider the amount of A to be X, amount of D will be P minus X. This is just like the initial equation, PV equal nRT. Temperature is kept constant, volume is kept constant, and at this time pressure will be directly proportional to the number of moles. Okay. Then this is X, this is P minus X. And after some time there is certain amount of decomposition. So if I consider the amount decomposed from A to be Y, formed is Y by 2, here formed is Y by 3Y by 2. Here if I consider reactor to be Y, formed is Y, C formed is 2Y. The amount of C that is formed is 2Y. But you know the total pressure, which means X minus Y plus P minus X minus Y plus Y by 2 plus 3Y by 2 plus 2Y. That is equal to 2.7 P. 2.7 P. So here 1 P, here 2.7 P. If I take it to this side, 1.7 P. 1.7 P. Plus X minus X cancel. Plus Y minus Y cancel. This P was taken to this side now. So for my, so that I don't make any mistake. I put the P this side. No issues. No. It's just you're playing with numbers. That's it. Then here 3Y by 2 plus Y by 2 means 4Y by 2. So this is 4Y by 2 means 2Y. 2Y, 4Y. 4Y minus Y, 3Y. 4Y minus Y, 3Y. So Y will be equal to 1.7 P divided by 3. 1.7 P divided by 3. Okay, that is Y. Y means what? The amount that has been dissociated. The amount that has been dissociated is 1.7 P P divided by 3. Okay, we found the amount dissociated. Now we'll look at how the rate varies. Rate equal to, since this is elementary, K1 into A gas concentration square. But PV equal nRT. N over V equal to what? NOV equal to P over RT. So this should be P over RT squared. P over RT squared. Whatever the PA gas into K1. So your answer should be P over RT squared term should be there. So from that you can neglect the first two answers. Yeah. You can neglect the first two answers. Okay. Now what else can we do? We know the amount that has been dissociated. But at the same time you know that X no. They say that there is complete decomposition of reactants. So what should happen here? This minus Y component should not come. What we had done the question is looking at equilibrium, but here no equilibrium. So this will be y by 2, x by 2. This is 3x by 2. So then this will be, so if I just imagine, this is P no. This is P minus X. This is the amount of D that is present. So this is also P minus X. So then this will be 2P minus X. So this will be 2P minus X. You have to consider that there is complete decomposition. It's given in the question which I did not see previously. So P minus X into 2. Now it's easy. X won't be there within our solution now. So here x by 2 plus 3x by 2. 4x by 2 is 2x. 2x plus P minus X plus 2P minus 2x equal to 2.7p. 2.7p. So here we have, look at this carefully. Plus 2x minus 2x cancel. So this side I can take x equal to 3p minus 2.7 is 0.3. 0.3p. That is x. That has been the initial pressure of A. So I can just put it here. So that is equal to K1 into 0.3p squared divided by R square T square. So that is 0.09 K1P squared divided by R square T squared. So I think they have taken P over RT constant. So your answer will be the third one. For question number 19, your answer is answer number 3. 0.09 K1 into P over RT squared. You just have to consider that they completely dissociate, and important, initial rate. So you have to come up with the initial pressure exerted by A. Okay, this was also a very good question. Okay, question number 20. An organic compound X decolorizes bromine water. Okay, if it decolorizes bromine water, for sure there should be triple bond or double bond. Then only bromine will go and attack there as electrophilic addition reaction. Okay, so if there should be decolorization of bromine, then what is the conclusion that we can come up to? The presence of a double bond or a triple bond if there's decolorization of bromine. So fifth one is wrong according to that. There's no triple bond or double bond, so fifth one is wrong. X doesn't give precipitate with ammonical cuprous chloride, which means there is no acidic hydrogen. Only if there was an acidic hydrogen, that Cu will go and replace the H to give a red brown precipitate. So that particular precipitate is not there. So 1, 4 is out. 1, 4, 5 out. Now we have to play with only 2 and 5. When X is heated with acidified dichromate solution, green color solution is obtained, which means X should have the ability to undergo oxidation. So it should be either primary alcohol or secondary alcohol, or it can even be an aldehyde. But it should not be tertiary alcohol. If you look at the second one is a tertiary alcohol. Tertiary alcohols cannot undergo oxidation. So therefore the second answer is wrong, and your answer should be answer number 3. For question number 20, your answer is answer number 3. So this marks the end of yet another video with Moments of Chemistry. So today we had discussed from question number 11 to question number 20 of the 2019 paper. So please do contributing your support towards us, and hope to see you in our next video. Stay tuned for more. Thank you. Hey everyone, I think that particular video had added some amount of advantage to your pinnacle of success. Chemistry will indeed become one of your most favorite subjects at the end of what we take as a journey. So don't forget to like, share and subscribe this particular channel with those whom you like. And wait, whether your comments are advantageous or disadvantageous, please do put them down in the chat box, because everything amounts to us. So thank you and have a nice day.